Important day today. We're going to talk about classes some more. We've seen classes. Again, this is another one of those lectures where most of the material we've seen one way or another. We've already talked about classes and class members and properties, and saw some constructors. And today we're going to dive a little more into that. Especially we're going to talk about access modifiers, which are important part of any object-oriented class system of any good programming language. And we'll see some other stuff. There is one thing that I want to cover, which is not listed and not included just as a demonstration, because I've been asked, at least in the two last sessions, about the special case of the string class. So because in all the normal classes that we are defining, we are calling a constructor and creating an instance, but with string, for example, or int, you can just take literal values and say this object equals something, and you got yourself a class. So we'll see a little bit about how this one works and how you can make your own. And a few words about structures, which are almost the same as classes, except that they are living in different areas of the memory and managed a bit differently. And one more thing that I wanted to show, which is not shown today on the normal demos, is maybe giving a few words about destructors as well as constructors. So, we're going to start with defining classes, and we'll see. As we've already mentioned, classes are some kind of imitation of real-world objects. This is good whenever you have the object-oriented model of encapsulation and hiding the data that you don't want to hide. But basically, when you can create an object, it will contain some properties that define it. So you can talk about a person or a car or a workplace or anything like that, as well as some things which are more, let's say, on programming level, like operations or like events or operators that define a class, which we're not going to be looking at today, but they are supposed to be, let's say, wrapped objects that contains several properties which are exposed to the world and several functionalities which are exposed to the world, and some things which they are doing internally as well. So this is pretty much what we've already discussed, and we're going to see in greater details today how they're structured and what they contain, and maybe have a few words about what they need to expose to the outer world and what they don't need to expose to the outer world. That's an important concept of object-oriented design. So as we mentioned, classes they can have fields and constants, which we've seen already, but we'll look at those. We've seen methods. All these can be static and non-static, and we've already seen the static version of them. Today we're going to look more into the non-static ones, which are specific to every instance of our classes, what we call objects. All the others, a bit more advanced topics like indexers, events, operators, we're not going to be looking at those today, but it's good to know that they can have those, let's say, particles. Constructors and destructors, we're going to look at constructors a little today, and I'm going to show a little. I'm going to give a few words about destructors as well, because I don't think they're mentioned properly. And classes can contain other classes built into them. It's not a very common scenario, but a class can have a class defined inside it, and that's something. Delegates, by the way, are not completely related to classes. and we're not going to mention those today either. We're going to look at those access modifiers, access control, keywords, public, private, protected, internal. We'll see what's the differences between them, also very important, and static that we've already seen, that are not specific for a specific object, but they are specific for the whole class, and they are like global properties or global fields or global methods. And so here's an example, first example of a class, and let's break it down. First of all, we are using the keyword class, of course, and we have the name of the class, which is usually an uppercase word or collection of words, which have to be, in any case, it has to be put in one word. In this case, we see a class which inherits another class, and that means that we have some kind of hierarchical structure of classes here. We can go up the hierarchy and into more abstract classes, or go down the hierarchy into more concrete implementation. So, for example, we can define a class which will be called animal, which will have some properties which are common to all the animals, and then we can create a class called cat, which will have all the properties of animal, which it's supposed to have. Of course, animal can have properties which are hidden from the cat class, and it can has its own. It can implement its own. It can override things, so that it can be more specific. It can be like a kind of an animal. So here we see an example of an inheritance of classes. If the example is not very clear, we might take a deeper look into a more detailed example.
But the animal class is defined somewhere else.
Yes, it is a different class. To those of you who have been, by the way, using C++ or other languages, for example, in C++ we have multiple inheritance. You can take several classes and they can all be inherited into one class. So it can have all the properties of animal or the properties of cats, for example, which encapsulates all the different cats. Other characteristics like home, domestic animal, anything like that. So in C# we have only one-to-one inheritance. We don't have multiple inheritance at all. We do have other solutions like interfaces, which can be used, but the classic multiple inheritance is not part of C#. That's something that sometimes surprises people. You're surprised? Yeah.
Is there some reason for that?
Yes, there is a reason for that, and I don't know it, but I'm sure there is.
Keep it simple.
Well, I'm not sure that's the reason.
Design is finished when you cannot remove anything, not when you can add anything. When you cannot remove anything, then you finish with the design.
I'm not sure that the simplicity here is the part. C# is trying to be more definitive of the object-oriented design ideas. So, for example, another thing that we're going to discuss today is the access modifiers, that in C++ you have something like friend. So classes can be friends, and they can access each other's protected properties. No friends in C#, for example. So why? Because in the case of, for example, friends, we want to keep classes really separate as much as possible, and not, these friends, as you know from Facebook, are worthless, and no, this doesn't work well if you're really going into the hardcore of object-oriented ideas. So I guess that that might be also part of the reason that multiple inheritance is not implemented. You can build your own hierarchy maybe in a different way. Or for example, you can use interfaces. We haven't seen much of interfaces yet, but interface says, okay, instead of taking an animal, I will make this class have some characteristics of an animal, but it will have to implement it itself. And that means that when I have a cat object, I know exactly what to expect, what it implements, and how it does it, and it does it in its own way. And it can have multiple implementations of multiple interfaces, but not specific, not of actual classes. So maybe it's less messy, but I doubt this is the reason. Okay, let's go into the class. What we have here is two private fields. They are uninitialized by default. Name and owner, both of them are strings. We'll talk about the privates a bit later. Here we have a constructor that initializes those two fields. And as you can see, the arguments in the constructor signature have the exact same name as the fields, with the same case sensitivity and the same name exactly. We're using here the word this to address the current created instance of our class, the current object, and we can address through that all its properties, fields, methods, events, and etc. I'm not, of course, in most cases, it's not required to use the word this when you are addressing inside your class something, but it is good practice to always do that so that it's not ambiguous to the reader. And in this case, I think it's also not necessary. We can check that, and maybe we will. And even though, in this specific case, it might be ambiguous to the compiler as well. But it's smart enough to differentiate this one from this one.
This dot name is different than name.
Yes, this dot name is different than the name in this case for sure. And I'm not sure if it will work without the word this in this specific case, but it's always good practice to use this when you're addressing inside your class, inside an instance of a class, some other parts of the class. Usually it's also not so good practice to use the exact same name here and here, so that we'll have the same name of the field as the same name of the variable here, because in this case we have in the same scope two variables which are exactly the same name. And even though it says here this, I don't think it's very good practice to have in the same line two different variables which are unrelated to each other but have exactly the same name. It's not very nice. That's what I'm not certain. I think the compiler will have a problem with that. And if it doesn't, it should have a problem with that. And that's why I think it's not the best way. However, what we have here is a property which is public. Again, it's a string, and again, it's a name. And it has a getter and a setter, so that whenever we are calling our class dot name from the outside, since this is a public property, we will get a string back, and what we will get back is the value of the internal field name. This is a very commonly way to expose internal fields as properties. I think we've also seen that we don't really need to implement a specific field. We can just say get and set without any body. So we can just put a semicolon here and here, and that would still be valid. But once we have here a body, a block of code, we can do other actions as well inside our property when it's being retrieved and when it's being set. And this value here is the value that is being set into the property. So when we have a cat and we say cat.name, equals something, this something will get into here, will have a value, and will be assigned to the internal field name. So that's one way which is very common, to have internal fields which are managed only by the class. Nobody needs to address them, nobody needs to touch them, and only the class can put values into them when the class sees right. That's an important thing to know, that your class must handle its own things and not to expose what it doesn't need to expose. And when we are exposing something, we can also not really do anything with it. We can, for example, when we're setting something, we don't have to really set anything. We can just say, don't do anything in this block, so that the class chooses what to expose and what to do.
In this case, when we are defining some variable in class cat,
Inside
we
the class.
No, we are just defining some variable that it's
Of type.
new class cat.
Yes.
Do we have for sure to set the name and the owner and use it, or we can just say new cat?
Since we don't have a default constructor here, I think you will not be able to run it without calling this specific constructor.
So we have to put some default values
Yeah.
to be able to.
You will have to produce a default constructor. Constructors can overload each other. And you can have several constructors with several structures. So in this case, we can have a constructor that has a name and an owner, and it has to be supplied when you say new cat, you have to write a name and an owner. But you can also put a constructor with an empty, without any arguments, which will be side by side to this constructor, and then you can say new cat without any initialization arguments, and it will be whatever you want will happen inside it. You can set values to default, you can set them to empty, you can do nothing. That's also fine. And
The string class. Maybe in the string class they put a constructor with nothing.
Yeah, we'll look at that. It's a little bit more than that. There is some implicit conversion.
They have about 32 overall.
Yeah, no, I don't mean that. I mean the fact that in string you don't have to use a constructor. So if this was implementing the same way as string, we could say cat A equals something directly without any call to a constructor. So it's possible to do that. I'll show you how. We're going down the class here. We have another property, public. The owner, which behaves exactly like the name property. It corresponds with the inner field, either returning it and setting it. Getter and setter, of course, don't have to be both of them. You can set only a setter, only a getter. You can set one of them to be private, for example, or protected, or internal, or whichever way that you want to manage your data. And there's a method here. I don't think that's the way to write meow, but it's a public method that can be called on any instance. It doesn't do anything special, so in this case this could have been a static method, because it doesn't correspond to anything which is state related to any of the fields which define in the object of the class, just doing the same action anyway. So this could have been static in the way, and that's the end of our class. More questions about this class for now?
One more thing. Anymore.
Mhm.
It's base class.
Yes.
What properties do you get from it right now?
Depends on what it defines, but anything which is
Animal has its own constructor.
you can invoke it. You can invoke it from your own constructor. You can go to the base class constructor and make it run. maybe we'll see about that too. We're not going to talk much about inheritance today, but maybe I'll show an example of maybe this example. We'll make an animal and a cat, and we'll see how they. But when we're going to talk very soon about public, private, protected, and all that, and whatever is defined in animal as public and protected, or internal, if we are still in the same assembly, we'll also discuss this, then I can get from my cat object as well. More? So yeah, what we've seen, we have the declaration of the class, we have an inherited class in this case, so we have the inheritance. We've seen fields, constructors, properties, methods, all the rest. There are many more things that can be defined inside a class, but we're not going to discuss those today. Important, access modifiers. The principle of encapsulation, one of the most important ideas in object-oriented design. Once we have classes, it's important, like I always repeat and say, let them do their own job inside. Let them be a black box. Whatever the world doesn't need to see, doesn't need to know, doesn't need to meddle with, don't let people just go to your cat class and into your field and change it for you. You need control. The class needs to show on a need-to-know basis. If somebody needs to access some part of your class, that's okay. Otherwise, you have to think whether or not these things are should be accessible to the outer world, and to which outer world. I can tell you that in my team here, we have quite a huge project, and now there's a new policy, which is we're constantly adding new classes, new interfaces, new services into our, because we're adding new features all the time. And now there's a policy that if you are adding some class which is public, or has some public properties, or add some public properties to a class, we need to approve it with one of the team leaders, one of the architectural team leaders, because it's really important to think what you're exposing to the outer world, and not to just have everything out in the open. And if you're putting something which is accessible from the outside, you have to think why you're doing that. So in the case, think of something like a car, for example, or your laptop. You have your screen and your keyboard and your mouse, and sometimes you know a little more about what's going on inside, but you're not really going into what's going on. Treat them like a closed box, and consider what you're exposing. So we are dealing in C# with 4 different access modifiers. The public one means that whatever you put public is accessible to everyone. So if you have a public field or a public property or a public method, it will be accessible to anyone who has an object of your class, or if it's static, anyone who can access your class itself can reach those. Then we have the private ones, which are not accessible to anyone, only inside your class. Like those fields that we saw. If you're managing something and you think nobody should access it, then put it on a private. Protected is accessible from the class and from other classes which inherit the class. And that's about it. Internal is interesting. It's accessible only from the current assembly. So, for example, in many cases, when you're working on big projects, you will have different assemblies. I don't know if this is going to be demonstrated much, but again, I want to show this too. So, many times we have different features, different components of our project, of our product, which are in separate assemblies. I can define, for example, a console application, but if we go back to the cat example, I can make an assembly. I can make a DLL, a class library, which will hold all the animal classes and manage those. And many times I can build, for example, utility classes or classes which have some kind of internal functionality. So these I want to be used from other classes, but I don't want them to be used outside my closed assembly, outside my closed DLL. I want people to be able to connect to it. I want to refer to it. I want them to use this, for example, cat class, but I don't want them to access specific parts of it. Whatever is closed in a separate assembly is also like a higher version of encapsulation. So you can think about what you're exposing also at the assembly level, and that means you can mark them as internal. Let's see some examples and maybe some more examples. But I think, why do I think we're missing something? Because it's not a live demo, it's an example. Yeah, I remember that we're seeing it here.
Is this painting coming with the performance cost?
I think not.
It doesn't.
No. Some of the things can be already checked at compile time. For example, if you're trying to access a private property or set some private field from where you can't, your project won't build. Some things are, well, actually they're all in compile time because these things are checked. It's not affecting the runtime at all. So we're going to see an example class of a dog. Dog should have a name and breed. If there is no name or breed assigned to the dog, it should be named Balkan, and the breed should be Street Excellent. It should be able to view and change the name and breed of a dog. The dog should be able to bark. So here's our class. It's pretty much almost the same as the cat class, just that this one doesn't inherit anything. It could, let's say, it could also inherit from the animal class if there are some basic characteristic defined there. We have the name and the breed, and here we have two constructors. We have the default constructor here, which doesn't contain any arguments, and once we run this constructor, we are setting default values to our fields. And we have the second constructor that gets actual values from the outer world and sets the internal fields. These are the corresponding properties of those fields. So one of them returns and the other one sets. And we have a method, public method, which prints out a string and also puts the name field into the string, so that it will be producing different strings for different dog names. That's it. Okay. So we've already seen how classes are being used, and we're going to see that, of course, more. We can create new instances by calling the constructors. Once we have an instance of a class, what we also call an object, we can access the properties. We can invoke methods. We can handle events. We can also attach delegates to events and many more things. And that's it. I think we're repeating a lot of stuff here. So once we have a class and we want to initialize it, we want to create an instance, we're calling a constructor. And what happens there is usually initialization of the fields, but not just that. I mean, once you have fields, especially the private fields, you want to give them some defaults. That's a good time to do that when the class is being initialized. Manipulation, we have to think about what our class is exposing again. So the users of the class can read and change your properties. They can call methods. They can handle events that the class is raising. But of course, we know that already. Once our class object is released, that means that I've also mentioned that a couple of times. In C#, unlike C++, for example, we don't have we have an automatic garbage collection of our classes, which are defined in the heap. So once we're defining new objects of classes, those are always reference types, and they're always defined in the memory part called heap. They are allocated dynamically in memory, and once we reach the last line of where this class is used in the code, in a specific block, there will be at some point a process of garbage collection that will clear up the taken memory. That's usually done automatically. In C++, you have to define, you have a constructor that is called when you create the instance, but then you have a destructor, which is called when you delete the instance of your class. And then you can free all kinds of memories that this class has been using. For example, if your class is also allocating memory using another class, these have to be freed when your class is being deleted. That's a lot of work, and it leads to many memory leak problems. And in C#, there are less memory leak problems, thanks to the automatic garbage collection system. But still, there is an option to make a destructor to your class and release whatever you need, or delete things, or clear fields, or anything. Usually, it's not needed. I personally have never seen a project that actually uses a destructor in any of its classes, but the option is there. If you need to do something when the class is finished its service, or if you need to print something, do something, to identify that you've reached the destruction of an object, then you have the entry point. You can define a destructor to your class as well. So now we're continuing with the dog class. We are creating 3 dogs, 2 of them with a name and 1 without a name. Put them all in an array, go through the array, and make each one of them bark. And use the dog from the previous example. Okay, let's see what's going on here. We are reading 2 dog names from the command line through the console read line. We know how this works. And actually, we're doing it here for 1 dog. We're collecting the name and the breed, and we're putting them in some variables. Now we're calling the constructor with those variables to create an instance called the first dog. The second dog is calling the default constructor, so it's not specifying a name or a breed. And after we've done that, we are collecting the data from the console again and setting the properties directly. So the 2 ways to initialize those values. I think something is missing, but the array and the whole thing. No other slide. I think that's the end of the main method. Do you have it?
This is another slide in the side.
Then they updated it after I downloaded this. Okay, let's go to the code anyway. It's more interesting and see it in the code. So our project here has already 2 files. The first one is the regular main file that runs on your console, and we have a class in a separate file called dog. And here are all the properties that we've seen: the default constructor, the name, the breed, the properties, and the function. And as we've seen, we're collecting the first dog values from the console and creating it through the constructor. And the second dog we're not collecting it, we're just creating it with the default constructor, and then we are populating it from the console. And the third dog, we're not doing anything about it, we're just creating it with the default constructor, and that's it. That was also missing in the slide. Then we're creating an array of dogs. So you can use, of course, your class to put in any collection array, just like we've been using ints or strings. And for each one of them, we're going to then iterate in a loop and call the method saveBow, which is specific to each one of them. It will run with its own state, with its own values. Okay, so let's run it. The most difficult thing here is to give them names. Let's call it Bono. Let's say so here are our values. We have them in regular variables, as we all know, and we're calling the constructor. If we step into the constructor with those values, we're now in the dog class. In the constructor, we're getting the values, and we're setting the two fields. We're done, we're back. Now we're calling the default empty constructor for the second dog. So if we step into that, we'll see that it has some default values. Now we're collecting data for the second dog. Damn it.
You could be a people.
It will be. How do you write it like this? Oh, that's Brad Pitt. Should have named the dog Brad Pitt. Or is it one word?
Yeah.
Okay. So now,
Actually, here we could just put second dog name equals
yeah, we could do that instead of using variables. That's true. And now we can actually, if we look at the property that now contains, before the assignment, the default value, and we can, well, in some cases, we didn't stop because of the stepping, but if we take a look at the breed, with a proper breakpoint, we can step into the code here. And we can see that it's actually running just like any other code, like a method, and you can put any code that you want to be performed here. So this is not just a wrapper to your private field. It can really do some things. It can calculate things. It can anything that you think that should be done once we set this value, you can do it here, and that's quite powerful. So now we're here in this line, and we're setting a new value. And the third dog, again through the default constructor. Note that the default constructor assigns the fields directly, and it could have been, if we have something important here in the public properties, that we could have addressed the public property instead of the field. If something important is happening when we're setting this value, we could have triggered it directly from here as well. So this is again consideration to be taken. So now we have the dogs, and each one of them we can also look in the in the watch and see its properties. We can see that this one, by the way, is private with a little lock, and the others are not. And we're creating an array, so we can see them now in the array, and each one of them with its own properties. And we are iterating, and for each one we're calling the method. So here we are with 1, and even though we're calling the same method, we're just producing specific results for each one. And like we mentioned, if we remove this, it's still, oh, but that's not it. That's not the problem.
Yeah.
Now we have a problem. So always address, if you are in the class, in the context of a class, always address the properties, attributes, events, methods with this. Unless they are static, and then you cannot address them with this, because this contains the current object. Questions about the demo so far, or something we wanted to see?
Can we access the properties of the class and their properties? For example, here the name of the dog has its own properties because it's a string.
Mm-hmm.
Can we access the properties of the string to the properties of the dog class?
Yeah, you mean something like if we had a public.
Can we add, for example, directly to the string, to the name of the dog, directly with that name, that string?
Yeah, we could manipulate things here. I mean, we could, for example, have something like this, a property which is public and has a getter, and returns this dot name dot length.
But we have to specify. We cannot use it while we are not specifying it in the class.
Yes. Oh, you mean if we can, through these properties, access the actual values? Okay, if these are properties of reference types, you can access them through here, because this will return, we are returning here a variable which is internal to the class, but it is not internal, it's private to the class. But if this was a reference type, we could access it through that, and we can access the properties of that. So it does give you some kind of a way in to the variable in this case.
But right now we don't have any access to the properties.
To this one, directly to this one, we don't have. So, for example, if I said here that this set is private, only the class can set this thing now, and even though I'm getting it, I cannot set it, because the setter is done through here, and setter can be done only through the class, and this directly itself is not accessible to the outside world at all.
That was not a question. The question was, can we access the properties without defining any methods or modifiers to get directly to the
yes.
properties of the class?
Yes, if we have a property, for example,
we are in the class.
we are in the class, but this is a public property. I can define here get and set like this, without any field, and directly accessing it and setting it, changing it. Is this what you mean?
No, I mean, can we use it as a normal variable, as a normal unit?
Can I create a variable for this thing?
No. If
For
you,
the-
if you are not defining any method scientific right now,
Mm-hmm.
can you use its properties in the program?
I'm not following your question.
For example,
Yeah.
in the other program, can we concatenate some string to the name of the dog without using any methods here in the class?
Yeah, that is a static value. Value up there. It's a global. Then we can just manage it inside.
So you mean that you will have a property of the class?
And we have name
Mhm.
is a string.
Yes.
If we access it from the program,
Mm-hmm.
can we access its properties? The string property.
Any string that you can access its properties too. I mean, each one of these properties are public, they can be accessed, and their properties can be accessed too.
That was the question.
Yes. So if we're here
Yes.
in the dog, and I say
second
dog, yeah, let's say second dog. This is a string, so everything which I can do with the string, I can do here. I'm not changing its value. If I'm trying to change the value here to set some new value to it somehow, and it's a private setter, or doesn't have a setter. So, for example, I can say, in this case, the name length should only be returned. Nobody should be able to set it. So I can omit it completely. So you can control who can do what in your class, but in the end, once you have access to a field or to a property of your class, you can get just like any other object. So in this case, it's a string, you can get to the string properties, of course. Is this what you meant? Okay. One thing, well, I'm not sure we should, well, we won't talk about inheritance in this case yet, because we have more things to cover. So constructors, as we've seen, are invoked with a new keyword, the new operator, when we're creating instances of our object. There can be multiple constructors. They never have a return type, because once we run them, we know exactly the type that we're getting back from them. So it's actually, it's not a return type, it's just producing an instance of the object, and
They are returning this.
they cannot have a return type in their prototype. I mean, I cannot do this. There's no return. Whenever I define a method, I have to define what it's returning. And they are not returning actually this. They are creating this, and the framework returns it to the caller, but it's not a return value of a regular return value of a method. It is implicit in a way, yeah. Have to have the name of the class. They can have parameters. They can have overloading constructors that have different parameters, and they can also have, just like any other, particle. They can be private, protected, internal, public, just like that. If you think about a private constructor, that's a tricky case. So that means nobody can create through constructor your class. It's useful, yes. It's useful in special cases. For example, a classic case in design patterns, which is called singleton. Singleton, where you have a class, where this class is allowed to have only one instance. So if I define a class cat, I can only have one cat
At a time.
created. No, at all.
At all. If you destroy
It cannot. Nobody can create it. There is only a static method that produces it, or returns an instance of it, but it's in the class. It's static, and the constructor itself is called from it, and only from it. Nobody else can call it. Tricky one, but common in this scenario, which is sometimes common. Singleton is probably the most common design pattern used. So if you want to learn more about that, look it up. Here's another example class point, which has coordinates of x and y. These are private fields. And here's our constructor, the default one, that sets their values to zeros. Another example, person with a name and an age, string and integer. And here we have two constructors, the default constructor and the one which gets new values. This is usually what you'll do in Constructor. You'll go over the fields and make sure that they are populated in some default way, or according to the values which you are receiving. So here's an example of something less recommended. We have two constructors here as before. We are setting values of hours and minutes, but in the constructor that contains arguments, we are doing it in the constructor itself. Otherwise, we have inline initialization of our values here. It's possible, but I think it's better to have consistency and use the constructors in order to assign your preliminary values, and not like this, because in many cases this will not be looked at. It's possible, but it's again up to you as you decide. But let's say that the world standard convention is to use constructors in order to populate them and to set their correct value in each case. And using default values like this are less common, and for a good reason, I think. If we have two constructors or more like this, again we're at the point with the two integers. We'll look first at the one with the arguments that gets two values here, and instead of creating another constructor here and resetting the same values again, we can call the other constructor and make it call with specific values. So what we're doing here is we're reusing the other constructor, so that if you have some code here, you don't have to really duplicate it. You just have to say, in this case, these are the values that the constructor will get. It's much better, more compact, and
It's declared with the 2 points.
yes.
Now we are overloading the constructor in this case, because we have here sometimes
It has also a body of its own. In this case, empty, but it's first calling the other constructor. Let's see it in a demo, and we can play with that.
It iterates through the first constructor and then it iterates through itself.
Yeah, here's the example. And I can still write code here, like this. So if we're stopped here, let's put a breakpoint. And here Well, we have to see first where this is called. So let's go over the classes first and see what's up. So here is our three classes here. First of all is the point, as we've seen, with the two coordinates. And it also has a name property. And we have two constructors. The empty one that reuses the non-empty one. And the name, which is populated with the properties that we're sending. So we're actually formatting a string here automatically for the name. And we have accessors to our fields through public properties. We have the person class, name and age. We have the default constructor and the non-default constructor. They are separate with separate codes. And here we have our public properties again. And the alarm clock with the inline initialization of the two variables, so that the default constructor is doing nothing and the other constructor is actually setting values, and the accessors. So let's run it. Okay, first of all we're going to the person class and we're going to the default constructor. So we are now here. We're setting the two field values. So now you can see that they have default values set by the constructor. Second, we're creating another person with the argumented constructor, setting them, returning, printing them. Now the alarm clock, the two constructors, the one that did nothing, but we still have the default values which are set inline in the class, and the other one which used the normal argument constructor, printing. Now let's go into the point. So first of all we are initiating the other constructor. So this constructor called this constructor, and now it's called with values so that it can do whatever it needs to do. Set the name, and once it's done it goes into its own code and runs it too. So this one, which now was initialized to 0, will get 6. So you can reuse constructors, and then you can add your own code in case you want to add something to call the other constructor. It's used very much. Reusing constructors like this is used very much, because at some point you're making one big constructor that has all the initializations needed in the class, calling all the methods it needs to call, creating everything it needs to create, and then you can create overloads with default values without putting any additional code, just adding them with the right initialization variables here, and that's it.
Instead of this, can we type point?
No. You mean like this?
Yes.
No.
What if we have two constructors with the same number of...
Then you'll have also a problem. Like this. You cannot define more than one constructor with the same signature.
But how you are overloading?
No, I mean, if
Here-
you're overloading with the same number of...
Yeah, overloading constructors.
yeah, and...
So
we
they will
use
have...
this with the two... zeros.
No, you cannot have two constructors with the same number and the same type of variables.
With different types.
Different types you can. If this string, that's okay. but then either you call this with one option, with a string, or with the int. So you have to supply something different here, for example, a string. One more thing that can be added here, I think it's shown but it's not demonstrated, is that we can also define the destructor. Pretty much looking like the C++ destructor. But if we put a breakpoint in it and we'll run our program, let's say to the last line that these are used, so now we're done running all the things. We have our objects defined, they are constructed, they have their properties, and now we are exiting the block where these are used, and we're getting into the destructor. What you do here is up to you. Like I said, I've never seen it used in any real program, because C# developers don't usually handle garbage collection themselves, and they don't usually need to do anything at this point. But if you need to do something here, like saying printing a console write line point is destructed or something, you can do it. So it's another point to notice.
You can clear the console.
Hmm?
You can clear the console.
You can clear the console. You can do many things.
You're making some interface class for a game. Then you can clear the console.
Yeah, but this is specifically when your class is being destructed, and that's not some action which is relating to any functional user-oriented action, usually. When you're exiting a function where this class is being used as an object, the destructor will be invoked. So it's not...
Things, for example, deleting variables from the dynamic line.
Yeah, you could. You could write a log file, for example. Yeah, log files are great for destructors. Was there any more questions here? Where are we? Here. So properties, we've seen them.
Actually, I was interested. Do the constructors get same thing with the exceptions? I mean, I was thinking that some of the exceptions are thrown by the constructors.
Can be.
We use in the constructor throw
Mm,
some exceptions.
yes, you can.
So we can use try and
You can use try, catch,
catch,
throw.
in the constructor.
Yes.
Will be easy. Some common use of the constructors.
Yeah, it is useful. For example, if we have a constructor which gets a string, and we can say in this case, if anybody tries to call your constructor with a null or an empty string, you will not accept it, and they'll get an exception.
In this case, but if you go with any value, with no value, then you get this.
Yes, that makes sense. Many times you have a class and you don't want people to initialize it in specific ways. So exceptions are there to say you're doing it wrong. More before we continue. So properties, we've seen that they have their accessories, getter and setter. So they can be read-only, write-only, read and write, whatever you choose. You can also control this with a public, private, etc. So they'll give your class accessibility and your fields and whatever you want to expose, an easy way out. I really have nothing to say about this because we've seen the properties. So you need to define them as either they're public, private, internal, protected. They must have some kind of type. They must have some kind of unique name in your class. They can have a getter or a setter or both or one of them. And they can have some code which runs inside the getter or the setter. So here again the point, here are the fields, here are the public properties which are just exposing the fields almost directly. And here's a slightly different example which is much like the one that we saw with the dog example. So if we have a rectangle class which has width and height, floats, we can have a public area property which will return always a calculation, which will always be dynamically calculated whenever this property is addressed. And note that this cannot be set, so it can only be retrieved. It's a read-only property in this case. And it makes sense. If you don't want to work hard on your getter and setter and you don't have anything special to put there, you can just publish them as public properties with an automatic getter and setter. They will have underlying fields, but they'll be automatically created in compile time. And you can see them if you look through.
But the previous slide, instead of get, can you use
Not much you can use instead of get.
You can use method area.
Yeah, you can use a method called getArea, and it will return
can
this.
you just type return with multiplied by get without get?
No, won't work.
Because C++ you can't.
I don't remember really. I don't think that C++ doesn't work like this. It doesn't have this structure of properties. C++ has only methods in this way or fields. So this structure of gets and sets and the whole mechanism of properties is only C#. Not only, but .NET. So if you're not defining any body to your getter and setter, they can be automatically done for you. And of course here, if I want this getter to be only private, I can also say private get without writing anything inside again, but it will be still controlled who can access each part of this property, but you don't have to run any code if you don't want. So and here, by the way, what we're seeing is another type of syntax. We're creating a class with a new, and after we call the constructor, we have a block of code here that accesses the public properties and sets them without writing profile.firstname, profile.lastname, profile.userid. We can access them without specifying the class name if we wrap them directly after the constructor call with curly braces. It's very useful, it's used a lot, and It's just comfortable. So, example, the rectangle class, we're calling it here with the regular constructor, and we're printing out the values of the properties that are set by the constructor, and this automatically calculated property. So we have the fields, we have the constructor, we have the properties, and we have this read-only expression which is calculated automatically. So in the first part, we're just jumping into the constructor with the values, setting the fields, and now we're receiving, if we put a breakpoint in the right place, here for example, and here, we can see the values being returned and the code being executed. So we're returning the value of the field, and then we're returning the value of the area, just as the method would do, and the same for the second rectangle. Questions? Well, static members, we've seen them before. They are class-wide members. They are not specifically for our objects, not for our specific instance. They can be, of course, every part of the class can be defined static. And again, static is accessed without an instance. Non-static members are accessible only with an instance of a class. Inside the class, it's referenced by the word this, and outside the class by the object that you've created. Static is initialized. Whenever you use the class, you'll have the static there. If it's a method, you can immediately call it. If it's some static property, you can immediately access it. And non-static ones must have first an instance at hand in order to use them. I think we know all that, right? So we have a class here. The const also acts as a static member. We have a static field, so that one is private. It's private to the class, this array, but it is static, so it can be accessed, for example, from this static constructor here. So actually everything that we're dealing here with is not related to non-static members. And notice that the class itself is also static. That means it can have only static members inside it. Alon? A static method that returns a member of our array, and that's it. Notice that we have here a static constructor which has the same name of the class, just like a constructor, but since we are not really creating an instance and we're not really invoking the constructor here, we're just calling one of the static methods, and this will invoke also the construction of the static.
So if we invoke any method of the
Anywhere when you address the class,
it
somehow
goes through the constructor.
it will go through the static and it will, yeah.
Those.
So here's our class. Here is the static constructor. Let's put a break. And that's it. One static method. So when we run this, at first we are thrown into the static constructor. Since there is no explicit call to the constructor, there is no explicit implementation of the new object, so we're thrown into it first, and this initialization of the array is happening. How many? Oh, okay. So we're not going to wait for that. And now we're calling a static method, and that means just as a regular method. And that's it. Notice that this is slightly different than the slide, because this is the regular class where you have your main method which is invoked. So what we have here is not a separate class. We're just putting it into the regular console application class. So all these properties are here, and the main is also just a static method of the same class. So you can just call the static method from here.
Can we have a main without static?
No, I think it's a part of the implementation of these applications. No, it needs to have a static entry point.
So if we want to execute some class when we introduce it to our program, we just make it static.
If you're running it like this as a console application, yes. In other cases, there are other ways to. They don't have to.
I mean, it's kind
There is I think there, in Windows applications also there is some kind of static entry point, but then you're creating different objects like forums and controls.
If you want to make something, then to make something actual, to calculate it. Because calculating it's inside the class. But if you want to make something actually, then we have to make a static class. For sure. That's
If you want to make this outside in a separate class,
yes, if you want to ask, for example, again, we have some menu for a program, and these different options from the menu, there are different classes,
Mhm.
which are acting different in different cases. So if you want to actually do something,
what do you mean
then
actually?
we have to define static numbers. These classes, they have to be static.
What do you mean actually do something?
And draw something from the console, or ask for something, execute something.
Well, in this case, when you're building a console application project like this one, it has to be defined in a certain way in the project properties. And in this case, it needs to have one class with a method, with a static method called main, in order to. This is the entry point of when your program starts running by the operating system. Actually, by the CLR framework. So, in this case, yeah, you need this in order to, let's say, do something. But it can invoke other actions from other classes, and some of them can be static or non-static. You can make a class that will make a drawing, and then you can make an instance of this class, and it will draw into the console. That will work also.
But we can have only one name.
Yeah, for each application, yes. For each,
If we add another
yeah.
class in another CS file, then we cannot have name in this class.
I think it will not work well, but we can try. So let's add another static class. No, doesn't work. More about this. We're talking about constructors, and there's one little thing that I wanted to show outside of this demos. Where did I put it? Here. And that's the special case of using classes like the string classes being used. So I've defined the class person here. It's a regular normal class, and it has these properties. It has a uint, year of birth, it has a name, it has a method, and apart from this it has two constructors. One of them is the regular constructor that populates my fields, and the other one that uses this constructor reuses it. So if we're not sending for example a name, I'll send the string unnamed person, or if, for example, if you're not setting an age, a year of birth, I'll set the year 0 in this case. And when I'm printing out, I'm checking if the year of birth is 0, then I'm printing unknown year in this case. So what the interesting part here is this implicit operator, which creates a conversion. In this case, I can take a string and convert it into a type person. That's a static implicit converter, so it's not part of actually my person class object, but it will return an object of type person based on the name that you've given. Or for example, I'm taking here a year of birth uint, and it will convert it. That means it will create a class based on what you send here, or not based. That's up to you. But the beauty of this implementation is that you can have something like this. I'm defining a class, and I'm putting here a variable, and I'm just initializing it with a string or with the unsigned int. And if we look at the implementation again, when this is run, when this line is executed, I'm thrown into the implicit operator that gets this value from the assignment operator and then calls the new class. So I'm calling my constructor with a name. I'm calling from here, I've called the other constructor, and I'm returning an object. So this is actually creating an object with all the fields accessible, methods and whatever. For example, I can call the method here, or I can assign it with a number with the same, because I have an implicit converter to that one too. So I'm getting here the value that I've assigned, and I'm returning, calling the constructor, which calls the other constructor and constructs the person, returns a value, and so I have an assigned object here with my properties.
It's the same way that integer is.
Yes, that's the way they're doing it. So, because I've been asked at least twice about this, and
How did I do it?
yeah, so just like in the other classes, system.string this is an assignment, and what you get here is an object. So you can call its properties like length. Just wanted to show this. It's not very common. It's not highly recommendable. Many times when you're defining your own classes, just use a constructor. It's neat. That's the way. That's the convention. That's the right way to go. But if you want to look very cool, like this, then you can use the implicit operator, which I think is cool, but yeah. No, it's readable. It's a static method, let's say, that gets a string and returns an object. Since it's static, it's not really affecting the actual object. It's just it can return a new instance in this case, and that's it. But the only special thing here is that it's called implicit operator, and it's the name of the class, and that's it. Let's take a last chance coffee break and continue to the last part, then with our stuff. One thing that I wanted to mention, which was omitted here, and since we're talking about classes and access modifiers, let's go back to a code example. Here's my project. The easy way to add a class to your project is to right-click it and say Add Class, then give it some name. It will add it as a file to the project, separate file, and it will give it the namespace according to the project or according to the hierarchy of folders that you've given, and it will create the class for you like this. And notice that this class has no access modifier. It could be declared public. The default of classes when you're creating them is internal. That means they are accessible to other classes in your assembly by default, but they are not accessible outside your assembly. You can add, for example, let's add a new assembly to this project, and doing that by clicking the solution and selecting Add New Item. And in this case, what new item? Add, new project. And this project, for example, will be a class library. We can call it animals, for example. So in this case, we are added into the project. We have now two classes, two different projects which are running in two different assemblies. And when I build this project and go to the folder where it's built, I will see here in one folder there is an executable, and in the other folder there's a DLL which corresponds to the second project. So here I can start adding classes which have all kinds of whatever I need, functionalities, hierarchy, and whatever I put here will be by default internal to this class. If you want something to be external to this class library, you should define it as public. And when you're creating something inside your class, for example, a variable like this, it's by default private. So I can set it again as internal, public, protected, whatever I need. But the defaults are, when you're creating a new class, it's internal to the project that you're in, to the assembly that you're building, and when you're assigning new variables, properties, methods, whatever inside your class, they will be private by default. And the last thing I wanted to mention is that, of course, you can create classes inside classes. It's possible. Sometimes in rare cases it's needed. But the option is there. You can create a class which exists only inside this class. So since this class is private now to this class, if I have the constructor here, which will be public, I can create an instance of my inner class, but I cannot do it from anywhere else. Why is this important that you know this now? It's not. But I just wanted to mention, first of all, the comment about the defaults, so that if you're creating a class, adding a class to your project by the add new class, it's by default internal. And if you're adding properties, fields, methods, whatever, inside your class, they'll be by default private, unless you specify differently. And if you look into the Visual Studio folder and you make a search to a file called class.zip, you will find a file, C# file, that contains the default implementation of classes, so that if I create a new class here, it will go by the default template, and if I put there the word public, all the new classes that I create will be by default public. Because people, when they create new classes, add a class to their project, to their solution, to their class library, whatever project they're using, the first thing they're doing with this screen is typing public. Which makes sense, because many times we want them to be public, but many times also we don't. So that's it. Of course, there's no use to put private here, right? Because we're not in the context of any class, so we're not private to anything. So a class in itself cannot be private unless it's in another class. So the only options we have here are internal or public, and that's it in this case.
Is there a way to access all the namespaces we have in the solution?
All the namespaces.
By default, because if we want to access some other namespace with these classes and methods, then we have to add it to the reference. But what's the point to have solution?
The point is that you can separate your things into different assemblies, and for example, assemblies can be reused in other projects.
But if we have one solution and we want to use everything we are using in this solution, is there some global option for that?
No, you have to add reference to whatever you need. And once you have a reference, you have to add a using to the namespaces that you are addressing. Okay. Any questions about this still? What I just said? It's beside the point. Just a few more interesting points to notice. Yeah, we're here. Structures. Very, very quickly, we'll go over structures. Structures are pretty much similar to classes in C#. They are extremely similar to classes in C++, but they are quite similar to classes in C#. They are in the way that they are defined. So if you switch the word class with the word struct, you're actually creating a structure. Structures are they can have everything a class can have. So just as I said, you can just use the keyword struct instead of class. They will always have implicitly a parameterless constructor, unlike classes, and they can have everything. They can have methods, they can have fields, they can have everything you need, but usually when we're building structures is just as data storage constructions, not as some functional component of your program. The reason for that is that they are not reference types. They're not reference types as classes, and they're not managed in the same way in memory. But that makes them also quite useful and quite efficient when they're used just for data storage. So here's an example of a structure. It's a point, it has x and y properties, both of them are public, they are both accessible for get and set. This is exactly as the way we would do it with a class, just that since this one doesn't need any special functional data, it just contains a structure of data to represent a point with two coordinates. We don't need any special things here, any events, any functions, any methodology, so we just use it as a structure. Same for a color, so we can define a color by red, green, blue value, just like we're doing, for example, with HTML, CSS. So we have a structure just to hold those values. Since we're not doing much more in here, it's okay, and it's just more efficient to use a structure in this case. And here's a more complex structure. It has more properties, and it has also a constructor that will run the original constructor first and then initialize all the values that it's containing. So that's also possible, just like you're doing it with a class. Okay, I think that's the last point that we're going to mention. Yeah, generic classes. They are pretty much similar, if anybody's been using, again, back to C++, to templates. They are basically just like any other classes that are used in the C# language, just that they have some kind of dynamic typing in them. So, for example, let's take a look at the example directly. We have here a class called generic list, and it's bound to a generic type. This one is used as a type, as a class that can be reused in the code inside the class. For example, if we're managing some kind of list of items, we can add an item to the list. And we can have different lists in this case. We can have, if we're talking, for example, about an array, it can be an array of integers, it can be an array of strings. But all of them will support the same functionality when we're adding an element to it. Only that they will have to be differentiated by the type that we're managing. So in this case, we can specify that we're doing a generic list of integers, and then this t here, which is specified, will be translated to the t which is used here. So if this one is used as integer, we'll use integers here as well. In this case, you can create one central class that can work with different data types instead of writing the same class again. And just if the implementation itself is similar, we can reuse the same code, just specifying that now we're dealing with a different data type. So here, for example, we're using this generic list class, and we're creating an instance here with integer. So this t, whenever we're running the class, will be replaced by int. Or we can create a
to specify the type.
Hmm?
Do we have to specify
Yes.
the type?
Yes. If it's a generic type like this, you have to specify the type that you're
Because
using.
I used it with dynamic code.
Hmm?
I used it with dynamic code. I'm specifying dynamic variable and then assigning it to
You cannot do it with a variable. In C# also there is a data type called type, which can hold information about several types. So this can hold information about int or about string, and they have their own properties in this case. But you cannot have a dynamically using a variable here in order to generate a dynamic type. Yeah, it's possible, but you have to hack it. You have to go through reflection. You can do it if you want to create it dynamically on a specific type. You can, but you have to use reflection, and that's not trivial. So the regular usage of it is to instantiate it like this by specifying the type. And in this case, once you have something which is generic enough in the code, it can cover different types without you duplicating your class. And that's very useful in a way. So for example, we have collections, many collections in the C# language, like list or dictionary, which are completely generic, and you can have a list of integers, a list of dogs, a list of persons, and each one of them will have the same add method that will do it, or get you the count of the items in the list, or anything else which is with all the actions that you can do in the list will be done the same way, just that they will be done with different types. So you can create any list of any kind. And that's the most trivial example to give, but there are many other generic types, and you can create your own generic types if you need to reuse some code with different values, with different types. So when we're creating the class, we don't know the type of T, but it has to be some kind of, we have to assume that it's some kind of type. That means represented by some class. And once you have it, you can just reuse it, and you just have to make sure that what you're doing with it doesn't really directly assume that T is something. That means you cannot assume that, for example, in this case it's an integer and address the properties of an integer in this case.
We can assume it's some kind of interface. We can assume it's some kind of interface.
In this case, no. You can create a constraint and say, okay, this is my generic class with T, but I want T to be inheriting from animal class, or I want T to be a specific interface. Then this will not work. This code here will fail to build because it says this class has constraints, and it cannot work with integers. It needs to be working with classes of type such and such.
Then there is no point to use this class.
There is a point. If you have 40 different classes which inherit from the same one, and you want only them to be used, but you can reuse them for any type of those 40 types. Instead of typing the class 40 times, you can create a generic class that will manage just them. Or
how you are handling the properties of this class when you don't know anything about the T?
you know that they are objects. So
You
you
have to add
Yeah,
the
no.
20 different exceptions.
no, you can check if it's null, for example, and then you can say the object is null and throw an exception. You can also check the type in the method. You can check when you have an object of type T, you can check if the object is int, do something. If it's a string, do something else. You can, but really up to you. So this is really used in a way that in ways that you don't care about what the object is. For example, if you want to implement an array or a list or a stack or anything else that just handles them as objects and not really digging into their internals, then it could be a generic class in this case. We use it a lot. I can tell you we use generic classes a lot, and in our system, for example, we have different parts of the systems which are managed by specific classes. For example, you have a class that manages the users that enter the system, but the implementation could be implemented in different inheriting classes, which could inherit different specifics. And then you can say, okay, this is my manager class, and here I'm putting some type that has to have such and such methods in it, and then I can replace it with different implementations at runtime. It's very flexible, but you have to. It's not very intuitive if you see it for the first time, but it's very flexible for building such dynamically typed classes. So let's see a live demo of that. Here's our dynamic generic class, sorry. And it's implementing some kind of list. And it's implementing it through an array. T is our type. And since we don't know what is T, we cannot assume anything except that it's an object. So we have here a private array of type T. We have a constructor that will initialize this array of elements of type T with the capacity that we're giving. We have a default constructor that calls the other constructor with the default capacity that we have here, which is constant. Then we can have the count of the objects in the array. We can add an element to the array if it's in the bound. Or we can access an object in the array through this accessor here. This is the way to access a specific index of your type.
The int
Yes,
part
this.
of it.
Yeah, and that's how arrays are doing it. And so we've seen some.
There should be one more exception. If it's less than 0, because the capacity is less than 0.
Yes, it's true. And I think that since we are trying to access an array with an index, it will be thrown for us. I mean, we can throw it ourselves, but it will be thrown for us because we're trying to access something. But here we're just checking something that we know, that we have a capacity that we have specified, and we don't want it to exceed it. Even though if we try to access, since the array has been initialized with this capacity, once we try to access it, it will be thrown anyway. That index is out of bound exception.
That's interesting. With the exceptions, how deep we can go with the exceptions. Avoid getting the exception for skipping the loops.
Yeah, you can try. So here are two different implementations of lists. We have our generic list of type integer, and we're calling the constructor, and we're calling the add method. And if we look at the add method again, it takes an element of type T and just inserts it into the array and increments the count so that we'll know how many elements we have. So once we are doing this into an array, we don't really need to know what is T. And we're not addressing the T here in the function at all. But we can call it with any type in which we defined our class. So we can have different lists, ones with arrays, one with strings, completely living in peace, and they save a lot of recoding. Very useful. So let's see it run. Build errors, right? Yeah, that's because we've added another main. But do that. Here. Okay. So once we're creating an instance of our generic type, we can see that the inner types are actually strongly type defined. So what we have as the elements, as the private field elements, is an array of integers. This is already strongly typed. So we're adding to the list, and when we call the add, we can see our call. We cannot see t in this context for some reason. No. I wonder. Yeah. So we can check the type of t in this case. So since t is just like as if we would type int in this case, at runtime this is what it knows, and this is a strongly typed array. We're adding it the elements. The count is returning just the size of the elements in the array that we've counted. It's not related to t. And now we're typing the elements, so we can stop without a breakpoint. But we could put a breakpoint in the getter and then jump to it. So here's our index, here's t, and we're just returning the element in the array. We could just return this, but here we're defining a variable of type t and assigning a value to it. And that's it. We're too much jumping now. So let's jump away. And again, generic list of strings, so that our string list is now contains an array of strings which is strongly typed and initialized to the default value of null. If we look at the add method which is invoked, we can see the element. We can inspect the type, which is now string, and we're just using it as a regular array just like we did before. Accessing an object is exactly the same, so that we're producing a variable of type t and taking the index out of the array. Nothing special to see here except really the usage of the t as the generic. I think you can use any letter here, but t is the common convention for the unknown type. Questions about generics? It's quite advanced, but it's powerful. It gives a lot of flexibility.
Increases the level of abstraction.
Yes, by far.
Can you use a constructor with speed?
Yes. Do you? Actually, the constructors are not generic. No, I don't think you can
Ah,
use it.
Then we cannot have structure
Mm,
because structure is useful.
yeah, but I think you can use it in a constructor. That's a default constructor again. So you can reuse T in the constructor. So
Maybe it will get its type when it receives the value.
it will get a type here, and I can use this as an object of the type T that I'm expecting. So it can be used in the constructor just as well.
But you can do any mathematical operations, for example, with the list afterwards, right?
You mean going to the elements themselves and doing some operations on them?
Don't know with their string or
No, you can check their specifics. For example, if type of T
Can you say T is int?
yeah, you can also say T is int. Or like this. Or you can say like this. You can try to cast it. No, you can't try to cast it because it's not an object.
You can parse it.
You can't parse T because T is not an object. It's a type.
You can parse
So you
all
cannot
the-
cast it. You can only check the type.
If it is, then define it with some variable.
Then I can go, for example, to elements at some position, and I can extract it as an integer, for example. So I can analyze the type of T at runtime, and I can do specific actions according to that, but
Can T be things like a structure or a class?
yes, of course, can be anything.
It can be a structure, it can be a class, it can be object.
It has to be some kind of defined type in your system, but because it's not an
Not
We
be an
are defining
operator.
types of.
hmm?
We are defining some types of.
Yes, but I mean, this is not an object. This is not an instance. This is a type. It can be a class. It can be a name of a class that you've created. It can be a class from the framework. It can be a generic type in itself. I can put here system dot. Wait. I can create something like this if I use the generic type. No, I'm missing something here.
Because there's already a class int.
Yes, I'm using. No, but that's not my point. You can create a generic of generic. I just have to think it for a minute.
At least it be.
Hmm?
So it will put a list of things because list it's generic.
Yes, but
It will be the same in any case.
Mm,
Generic or generic?
yeah.
Tier of some other.
Yes, yes, but you can. Can have some constraints here, and they can have also some generic constraints, but no, I'm pretty sure I've implemented or run across a double generic, but I have to refresh my memory about this one.
So the where keyword.
The where keyword says what is your constraint.
But it's not a good constraint.
Well, this one is not a good constraint. Mm,
It's not a constraint.
yes, but could be system collections, generic list of T. So everything that inherits from this type is okay to be used. Hmm?
List of lists.
Yes, in this case. And this will no longer build, of course.
Yeah, it requires list of parameters.
Yeah, it's a bit confusing in this case because it's an. If you're trying to put int, then it will require it to be a generic list of int.
Huh.
So yeah,
No, it's a constraint.
where you cannot actually, you're having here a pretty impossible constraint. Play around with the.
If we put it on interface, then it's not going to be a generic. It's
Yes, you can create you can have generic interfaces too, and you can specify. You can have generic interfaces, and you can specify that your type, the type used in your interface, the type used in your generic class has to implement specific interface. That's also possible.
Some couple of words how you define interfaces, perhaps, because we've talked about.
We've mentioned them.
but we haven't.
So if you have a class, and here I put all the things that the person needs to have. If I change the keyword to interface, usually it would be added with the letter I, like that. And here I can say a person needs to know how to walk. That's now a constraint. So if I create a class, let me magnify, person, which implements the interface of iPerson. Now this class must supply a method called walk, which returns void and takes no arguments. This will not build. It must implement a member. So if I implement it here, I'm implementing the interface. And if I'm having some kind of constraint here, this means that now I can have assumptions that T must support this method. I can actually go to my code and say T is not an object, but wherever I have an object of type T, for example here, I know that it must have this function. So it's no longer just arbitrary object, it's constrained by an interface.
And it's actually different objects can get the same interface and we can use it.
Yes, yes. If I'm implementing a new class
There is
here,
another interface with different objects using the same interface.
yeah, it must have now a function like this. It can be implemented completely differently. It probably will be. But
It
if
will
I'm
work
looking
on
at...
four bits. The child will work on 4 bits.
Yeah, but if I'm working with some generic class that has a constraint that means this must be implementing this interface, then I'm safe to know that this class has the methods defined by the interface. It's an agreement between the two. It's a contract. It's an abiding contract. That means this class is obliged to have this and that, and I know I'm safe that when I'm using a class which implements this, I know that I can surely assume that it has this and that.
So when we're defining interface, it's only a list of functions. That's the whole.
If we want to make some class which has all the mathematical methods inside, abstract, multiply, everything, then we would have to define the easiest way. We know that we will have all the methods. That we're saying that our class is from interface not comparison, but
I comparable if you want them to be sortable. If you have a collection. Yeah, many times like this, when you have something which is which you want your class to be able to do something, the framework also uses its own interfaces. And if you implement an interface in your class and you implement the expected things, then the framework can assume that it has this functionality and it can safely run these methods from your class. So if it needs to sort something, then and your objects are supporting the comparable, for example, then the framework can know that it can call the comparable and compare two objects and sort. So that's the power of interfaces. And unlike inheritance, a class can implement multiple interfaces at once. I think you'll encounter interfaces in the future as well, but let's not go any deeper than this right now, because it's late and we're losing the crowd. So, classes, we've seen them. They are real-life exemplary of real-world objects. We've seen the constructors. We've seen even a little bit about the destructors. Again, think about what you're exposing with your classes. Think about what parts of your class need to be static and which ones are not static and which ones are shared between the instances and which are not. Think about what you're putting as public and what you're putting as protected or what you're putting as private. We've seen a little bit of structures, which are in their syntax just as classes, only that they should be less functional because that's their aim. And we've also seen some other examples, like how do we imitate the behavior of the string initialization with an implicit operator. A little bit more about generic classes and interfaces. And any more questions before we sign it off? All right. So